Morning students, welcome to Unacademy, welcome to Kreatryx and welcome to Impulse batch. Before going to start the session, let me introduce myself. I'm KV Swami. I did my MTech in Systems and Signal Processing from JNT College of Engineering, Hyderabad and passed out in the year 2007. And since 2009, I was into this GATE coaching field, teaching my favorite subjects, signals and systems and communication throughout the country. I have 12 plus years of teaching experience and now I'm associated with Unacademy. And if you want to purchase any course on Unacademy, you can use my code KVS Live, with which you will be getting flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live to get flat 10% discount. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions, namely the Plus subscription and the Iconic subscription. In the Plus subscription, the student is exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the batch in Hindi, and if a student is not comfortable with Hindi, he can take the batch in English from his choice of educator. And we have rank improvement batches also. In Iconic subscription, the student is given a personal coach, a study planner, study booster sessions are there, personal test analysis is there, doubt clarifying instructors are there, and preparatory study material also given to the students. Coming to the fee structure, if a student is planning his GATE or ESE preparation in Plus subscription for 12 months, that is 1 year, it costs around 27,225 rupees only using the code KVS Live. GATE or ESE preparation in Plus subscription for 18 months, that is 1.5 year course, it costs around 34,650 rupees only using the code KVS Live. GATE or ESE preparation in Plus subscription for 24 months, that is 2-year program, which is ideal for second year students, so it costs around 39,600 rupees only using the code KVS Live. See, today there is a one offer that on 7th of April, if you are going to take the subscription in Plus for 12 months, subscription, if you are going to take, you will be getting the subscription for 15 months. You're getting the subscription for 15 months. So 3 months additional benefit you are going to get. Try to avail this offer, my dear students. And GATE or ESE preparation in Iconic subscription for 12 months, that is 1 year, it costs around 45,225 rupees only using the code KVS Live. GATE or ESE preparation in Iconic subscription for 24 months, that is 2-year program, it costs around 66,600 rupees using the code KVS Live. So whatever may be the subscription you want to take, either Plus subscription or Iconic subscription, don't forget to use the code KVS Live. KVS Live. See, this Sunday, that is on 11th of April, Unacademy is going to conduct an online exam known as Unacademy Combat, which is of 60 minutes duration, that is 1 hour exam, and the branches eligible are mechanical, civil, electrical, ECE and computer science and information technology. The benefit of this exam is, if you are lying in the top three positions, top 3 winners from each branch will get 100% scholarship, means they need not pay anything for Plus subscription, and top 100 winners will get additional discounts. So in order to write this exam, you can use my code KVS Live. KVS Live. Okay, and please try to propagate this to your friends also, my dear students. Okay, good morning Jaitirtha, good morning Manu, good morning Harish, good morning Adarsh. Okay, now today our discussion on the previous year's questions on the properties of systems, right? So let's see, almost all the previous questions we have covered in the discussions only, but there are some questions left which we'll be covering now, right? First question, This is given in 2008 ECE paper. So those who are coming new, please subscribe the channel and share the session, and type your attendance by pressing the like button, all of you. Now this is the first question. The input and output of a continuous time system are respectively denoted by x of t and y of t. Which of the following corresponds to a causal system? Causal system. Come on, try to answer this one. Causal system is asking. What could be your answer? What could be your answer? Voice is low. What is the answer? Please reply. All of you. Please reply. Am I audible now? Am I audible? Harish? Am I audible? Am I audible now? Okay, Harish. Right. Now, what is your answer? Causal system is what? Output at any time instant must depend on present and past values of input, but not on future values. So, among these four options, what could be your answer? Is asking for a causal system. Causal system. What could be the answer? Here, if you look at the options, option C will become the answer. Because if I take yt is equal to t plus 4 into x of t minus 1. Causal system is, again I am saying, output at any time instant must depend on present and past values of input, but not on future. You can observe the output at different time instants. So what happens if I observe the output at minus 1? It is nothing but 3 times x of minus 2. For minus 1, minus 2 is past value. What happens if you observe the output at 0? It is nothing but 4x of minus 1. For 0, minus 1 is past value. For y of 1 is 5x of 0. For 1, 0 is past value. So the output at any time instant is depending on the past values of input. So option C becomes the answer. Option C becomes the answer. This is given in GATE 2008 ECE paper. GATE 2008 ECE paper. Okay. So those who have done this one, you can take 2 marks. 2 marks. This is the first question. Now let's look at the next question. This is given in GATE 2012 for ECE Electrical and Instrumentation, 3 branches. The input x of t and output y of t of a system are related as y of t is equal to integral minus infinite to t x of tau cos 3 tau d tau. The system is, he has given options A, B, C, D. He is asking us to check time invariance and stability. Try to solve this problem. Try to solve this problem. You have to verify time invariance and stability. So what is the input output relationship? Yt is equal to integral minus infinite to t x of tau cos 3 tau d tau. So somebody saying Manu answer D, Jaitirda option D. Okay, let's verify. Now time invariance, input delay. Delay only the input. Input delay means what? Delay only the input. I think all of you remember the procedure. Here what we have to do, let tau minus t naught is equal to some k. D tau is equal to dk. Now phi of t comma t naught is equal to lower limit of tau is minus infinite. So lower limit of k is also minus infinite. Upper limit of tau. Upper limit of tau is what? T. So upper limit of k will be t minus t naught x of k cos 3 times tau is what? T naught plus k dk. This is input delay. What is output delay? Wherever you have t, replace it with t minus t naught. But we are having t here only, right? So minus infinite to t minus t naught x of tau cos 3 tau d tau, right? Now even if I call this equation as number 1, call this equation as number 2. Now even if I change the variable from k to tau in the first equation, so 1 and 2 are not equal. 1 and 2 are not equal. So this is not time invariant. Not time invariant. It is time variant. Time variant. Okay. So look here, not time invariant. So the option could, the answer could be B or D. So A cannot be the answer and C cannot be the answer. So if you filter the answers, so option B or D can be your answers, right? Here this is a peculiar problem, my dear students, observe. Now let's check stability, right? And what is the definition of stability? Bounded input must produce bounded output, right? So here in the process of checking the stability, minus infinite to t x of tau cos 3 tau d tau. This is the input output relationship, right? So we'll do one thing, apply bounded input, and our practice, normal practice is what? X of t is equal to u of t, right? Because u of t is a bounded signal. Bounded signal means what? Magnitude of the signal must be a finite value at any point of time. So if I apply u of t, what will happen? This will become, so as I am applying u of t, lower limit will become 0 to t u of tau. U of tau is anyway, or I can write like this, cos 3 tau d tau, but this is u of tau value is 1 cos 3 tau d tau. What is this equal to? 1 by 3 sin 3 tau between the limits 0 to t, or this is 1 by 3 sin 3t, which is a bounded signal. Observe here, my students, this is u of t is bounded, 1 by 3 sin 3t is also bounded. Sine signal is a bounded signal. So bounded input is producing bounded output. So bounded input is producing bounded output. So you may put it as a stable system. But what happens if I apply x of t is equal to cos 3t u of t? Instead of applying u of t, what happens if I apply cos 3t u of t? So your output will become 0 to t. 0 in the lower limit came because of this u of t cos cos square 3 tau d tau, or I can write this as 0 to t 1 plus cos 6 tau by 2 d tau between the limits of 0 to t. So what will happen if I integrate this one? This is 1 by 2 integration of d tau is tau between the limit 0 to t, it is t plus 1 by 12 sine 60 will come. Now if you observe here t came means what? It is growing, linearly increasing. So this signal t cannot be a bounded signal. Sine is bounded, but this t cannot be bounded. So overall y of t will be unbounded. In which case our system becomes unstable. No, here I am giving a bounded input. Cos 3t u of t is a bounded signal. Cos 3 u of t is a bounded signal. Bounded input is producing here unbounded output. So the system is stable or unstable? Unstable. So what is the option you are going to put here? It is not time invariant and not stable. Option D will become the answer. Option D will become the answer. Okay, let me check the voice. Hello, my dear students. Please reply. Am I audible now? Am I audible? Am I audible? Please reply. Am I audible? Check my voice. Vamsi Krishna, Harish, please check my voice. Am I audible now? Clear? Okay, fine. So there is a problem with this kind of questions, because if you are going to test stability with the signal u of t, you are going to get the output as bounded. But whereas if you are going to test the stability with the signals like cos 3t u of t, trigonometric functions, you are going to get the output as unbounded. So final answer is anyway, it is unstable system only, because it failed for one input. Now there is one more way, conceptual way of dealing this problem. So what he has given, what is the input output relationship? Y of t is equal to integral minus infinite to t x of tau cos 3 tau d tau. Observe here, students. Now what is the definition of stability? We know bounded input must produce bounded output. Bounded output means what? Magnitude of output must be a finite value. Bounded output means what? Magnitude of output must be a finite value. So we'll do one thing. Let's calculate the magnitude of output. Let's calculate the magnitude of output. Now take the magnitude inside. What I'm saying is take the magnitude inside. So if you are going to take the magnitude inside, we have one inequality called squares inequality, with which this will become less than or equal to. Now if you are going to take the magnitude inside this integral, this magnitude will break like this: x of tau mod of cos 3 tau d tau, right? So there is inequality called squares inequality, with which if you are going to take the magnitude inside, it will break like this and less than or equal to will come. And we know that for checking the stability, what kind of input will apply? Bounded input will apply. Bounded input means what? You know, magnitude of input must be a finite value. So one thing is confirmed, that this is finite value, right? Now cos 3 tau magnitude is, this is also finite. So we know that if you multiply two finite values, definitely we are going to get a finite value. Or I can simplify this as mod of y of t less than or equal to a finite value into integral minus infinite to t d tau. Right? Now if I simplify this integral, I am going to get an infinite value. If I'm going to simplify this integral, I'm going to get an infinite value. Infinite value multiplied with the finite value is what? Infinite value. So mod of y of t less than or equal to some infinite. Now what is the maximum value? Less than or equal to infinite means what is the maximum value of magnitude of output? It is infinite. Yes or no? So we are going to give a bounded input for which you are going to get an unbounded output. So the system becomes stable or unstable system? Unstable system. In this way also you can verify. Right? So this is not time invariant and not stable system. Hope this is clear for all of you. Yes or no? I suggest this procedure. Right? Even for your integrator also you can verify. What is your integrator? See, integrator y of t is equal to integral minus infinite to t x of tau d tau. How we verified? You apply x of t is equal to u of t. What will happen? Integral minus infinite to t u of tau d tau. This is nothing but r of t. So u of t is a bounded signal, but r of t is unbounded signal. So confirming that this is unstable system. Or you can simplify like this also, this procedure. Calculate the magnitude of output, which is nothing but integral minus infinite to t x of tau d tau. Now if you take the magnitude inside, magnitude of x of tau d tau, and we know that for checking the stability we'll apply bounded input only. For stability we'll apply bounded input only. Bounded input means what? Magnitude of input must be a finite value. So bring that finite value outside. So magnitude of y of t less than or equal to finite value into integral minus infinite to t d tau. And anyway this integral is going to lead infinite. So what is the maximum value of the magnitude of output? Infinite. So this is unstable. In this way also you can verify. Okay. Hope this is clear. Hope this is clear for all of you. Shall we go to the next problem? Yes. This is given in IES 2006 ECE paper. Try to solve this one. Which one of the following is the correct statement? The system characterized by the equation y of t is equal to a into x of t plus b is linear for any value of b, is linear if b greater than 0, is linear if b less than 0, and it is non-linear. Come on. Very simple question. Y of t is equal to a times x of t plus b. This is non-linear, no? Non-linear. Non-linear. Already we have seen. So option D becomes the answer. You can take 2 marks. The previous one also 2 marks you can take. Those who got the correct answer. Yes, linear if b is equal to 0. You are right, Jayatida. Fine. Question number 4. Let x of t be the input and y of t be the output of a continuous time system. Match the system properties P1, P2 and P3 with the system relations R1, R2, R3 and R4. I forgot to write the year. I think 2007 or 2006 this question came. Now you have to match. How you are going to match? First one is there. Observe here. T square x of t is there. T square x of t is what? Linear or non-linear? Linear. Time invariant or time variant? Okay, options are there. No, you can try. Please try. You try. Try to answer this question, all of you. Options are also given A, B, C, D. Manu has given option C. Okay. P1 R3, P2 R1, P3 R2. Manu. Okay. Let's see some more answers. After that, we'll verify. Today is the last class for the unit called systems, and tomorrow we are going to start a beautiful unit known as LTI systems. You will enjoy the third unit like anything. Options not fully visible. Okay. If the options are not visible also, you can do this, you can solve this one. Just map your answers, and after that anyway we'll be revealing the answer. Just map your answers, Manu. You can have a mapping between properties and relations. See, observe, if you observe here, look here, t square x of t is there. T square x of t means this is linear, we know, linear, and this is time variant, linear time variant. Okay, so first of all, forget about the answer. Let's spend some time on judging the properties. First one is linear time variant. Okay, second one, modulus operator. Whenever you encounter it is non-linear, t times modulus means non-linear time variant. Modulus non-linear time invariant is this one, and this one is linear time invariant, x of t minus 5. So R1 is what? Linear time variant, linear but not time. So P1 must be matched to R1. Observe here, P1 must be matched to R1 because R1 is linear time variant, and here on the left side P1 is also linear but not time invariant. So your answers could be P1 R1, means your answers could be A or D. You can filter like this. Your answers could be A or D. Okay. Now R2 is what? Non-linear. R2 is non-linear and time variant. Non-linear and time variant. So if you look at on the left side, non-linear time variant, I think it is not there. Not there. So forget about R2. Come to R3. R3 is what? Non-linear time invariant. Do you have non-linear time invariant? Non-linear time invariant. Yes, it is there. P2. So P2 must be matched to R3. Now R4, linear time invariant. P3 R4. Option A will become the answer. Please verify. Option A becomes the answer. It's not C, Jaitirtha. Jaitirtha, it's not C. You cannot map a P1 and R3. R3 is linear time invariant. Please verify. So it's a simple question. Okay, you can take 2 marks. Those who have done it right. Now look here. This is given in GATE 2006 electrical. In this question he said a continuous time system is described by y of t is equal to e power minus mod of x of t, where y of t is the output and x of t is the input. Y of t is bounded and he has given options A, B, C, D options he has given. Only when x of t is bounded, only when x of t is non-negative, some options he gave, and option D is even when x of t is not bounded. What could be your answer? What could be your answer? See, Manu D. Manu D. Manu, you are from which branch? ECE or electrical? Now here, if you look at the option D, what is it? Yt is equal to e power minus mod of which place? Mod of x of t, right? Now, for checking the stability, we'll apply bounded input. We'll apply bounded input. Bounded input means magnitude of input must be a finite value. Here, in this particular input output relationship, if my input x of t, look here, if my input x of t becomes infinite, or if it becomes minus infinite also, due to the presence of this modulus, I am going to get the output as 0. So here I can conclude that the output y of t is bounded even when x of t is not bounded. Even when x of t is not bounded. You can conclude that the output is bounded even when x of t is not bounded. Right? So you can take option D as the answer. See, if x of t is bounded, definitely output will be bounded. But even if x of t is not bounded also, output will be bounded. So option D will become the answer. Option D will become the answer. This is given in GATE 2006 electrical. Right. 2 marks you can take for this. Those who got the right answer, you can take 2 marks. Fine. Next question, simple question, nothing before you. The system represented by the input output relationship yt is equal to integral minus infinite to phi t x tau d tau for t greater than 0 is asking about linearity and causality. Come on. What is the answer? Option A, B, C, D and are given. What is the answer? Minus infinite to phi t x of tau d tau. If you observe, look here, this is linear. Integrated operator is linear. Anyway, we know. For causality, you can verify causality. And what is the causality saying? First of all, definition you must know. A system is said to be causal if the output at any time instant depends on present and past but not on future values of input. What happens if I calculate y of 1? It is minus infinite to 5 x of tau d tau. You are calculating the output at 1, for which you are coming from minus infinite to 5 of the values of input, but for 1, 5 is future value. So causal or non-causal? Non-causal. So it is linear but not causal. Linear but not causal. Option B will become the answer. Option B will become the answer. Option B. 2 marks you can take. Right, this one. Seventh one, this is given in instrumentation, GATE 2011. Consider system with input x of t and output y of t related as follows. Y of t is some d by dt of e power minus t x of t. Which one of the following statement is true? A, B, C, D are given. Come on, try to answer this one. The system is non-linear, the system is time invariant, the system is stable, the system has memory. What could be your answer? A, B, C, D are given. What could be your answer? I'm not getting any answers till now. Okay, Nandakumar has said that option D is the answer. Okay. Option D. Observe here. If you look at the option A, the system is non-linear. See, differentiated operator, it is linear. If you want, you can check the additivity and homogeneity. Apply x1t, apply x2t. In the third step, apply ax1t plus bx2t. Definitely you are going to get ay1t plus by2t for this one. So this is linear. So this cannot be the answer. Time invariant. Here, time invariant means what? Suppose if this e power minus t is not there, the system would have become time invariant because e power minus t is there, no? So input delay means will delay only this input. Output delay means along with the x of t will delay this e power minus t also. So in which case this becomes time variant. So this cannot be the answer. Time variant. Now the system is stable. Stable means what? Bounded input must produce bounded output, no? Right? Now we'll do one thing. Apply bounded input. Look here. Let's check the stability. Yt is equal to d by dt of e power minus t x of t. This is the input output relationship given. Apply a bounded input. So u of t will apply. What is that you are going to get? Yt is d by dt of e power minus t u of t. Now you can use the UV rule. This is nothing but e power minus t into d by dt of u of t plus u of t times d by dt of e power minus t. Now what happens to this one? Y of t is equal to e power minus t. D by dt of u of t is what? Del t minus e power minus t into u of t. This is what you are going to get. Now can you simplify this one? E power minus t into del t? Yes. See, we have this property, product property. X of t into del of t is nothing but x of 0 into del of t. From where I got this one? If I multiply a signal with an impulse signal, I'll get the same impulse signal with area changed. In this property, substitute t naught is equal to 0. You'll get this one. Now this becomes y of t is equal to x of 0. See, a t naught value is 0, no? So t naught value 0 means this becomes del of t minus e power minus t u of t. See, del of t k means for del of t is bounded signal, unbounded signal. Unbounded signal we got. So bounded signal I applied, but unbounded signal I got. So this is stable or unstable. So this is unstable system. Unstable system. Right? So this is unstable, but I said that it is stable. Now memory, whenever you encounter differentiation operation, yes, it is dynamic. It has memory. So option D will become the answer. Option D will become the answer. Those who have got option D, you can take 2 marks. 2 marks. Option D is the answer. Right? Fine. Let's look at the next question. This is given in GATE 2017 ECE paper. The input x of t and output y of t of a continuous time system are related as yt is equal to integral t minus t to t minus capital T to t x of u du. The system is asking regarding the linearity and time invariance. Come on, what is your answer? What is your answer? I think by this time you might have filtered the options. Integrator operator is linear, means option. So your answer must lie between must be in between A and B, because that integrator operator is linear. So answer could be A or B. A or B. So you have to check for time invariance. Check for time invariance. Nandakumar has said that option B is the answer, linear time invariant. Okay, let's see if other people get the same answer. Your answer may be right. Any more answers? Okay. So this is linear, pakka, that is guaranteed, linear. Now checking time invariance. Manu B. What about Vamsi, Harish, Jaitirtha? So input delay only the input. Delay only the input. We'll do one thing. Let this u minus t naught is equal to some k. Du is equal to some dk. So input delay y of t comma t naught is equal to integral. Lower limit of u is what? T minus t. So lower limit of k will be t minus t naught. Upper limit is t. Upper limit of u is t. So this becomes t minus t naught. So x of k dk. This is input delay. Output delay. While delaying your output delay is denoted by y of t minus t naught. Wherever you have t, replace it with t minus t naught. So t minus t naught minus t to t minus t naught x of u du. Whatever may be the variable, either u or k, these two expressions, the first expression and the second expression what I am writing, are equal. So it is time invariant. So as Nanda Kumar has said, this is linear and time invariant. Yes. Correct answer. Linear time invariant. Linear and time invariant. 2 marks you can take. Almost each and every previous gate question and conceptual question of second unit we are covering. In the first unit also we covered many problems. Let's look at the next question. This is given in GATE 2018 18 ECE paper. Let the input be U. So input is U and output Y of a system, and other parameters are real constants. Identify which among the following systems is not a linear system. Is not a linear system. Among the options is asking which is not a linear system. Come on, type your answer. See, differential equation is given. Differential equation is given means, look here, what makes the differential equation as non-linear? Suppose if you have a constant term, if you have a constant term in the differential equation, that will make your differential equation as non-linear. And if the coefficients are functions of the independent variable, no problem. But if the coefficients are functions of the dependent variable, there is a problem, right? Now if you observe, look here, constant term is not there, and all the coefficients what you are having, they are constants, and here U denotes the input and Y denotes the output. So first one is linear. Okay, second one, if you observe, integral 0 to t e power alpha into t minus tau beta u of tau d tau. Now u of here, this is input. So first step apply u1t, second step apply u2t, third step apply au1t plus bu2t. Yes, definitely this will also be a linear. Now if you look at the option D, this is in the form of y is equal to mx. Is a straight line passing through the input. If you try to draw the input output characteristics, yes, it is a straight line passing through the origin, so this will also be a linear. Now whereas if you try to plot the input output relationship for the option C, where u is the input, y is the output, so it has an intercept B. So this point is B. So non-linear, because we know that for linear system the input output characteristics must be like this. If u is the input, y is the output, output characteristics must be a straight line passing to the origin, but it should not have any intercept on the vertical axis. So non-linear. Option C will become the answer. Option C is the answer. Okay, so 2 marks for this one. 2 marks for this. Okay, 10th one. A system defined by y of n is equal to summation k varying from minus infinity to n x of k is an example for. Invertible system, memoryless system, non-invertible system, and averaging system. Come on, what is your answer? Any answers? Is an example for. A. Invertible system, Manu has said. Jaitirda A. See, if you observe, already we have seen yesterday while discussing invertibility, what is this operation known as? First of all, you must know the operation. What is the technical term? Summation or accumulation. Summation or accumulation. First option is, see, second option cannot be the answer. Memoryless system. Memoryless system means what? Dynamic system. What is the definition of dynamic system? Output at any time instant should not depend on the present. should not depend on, see, dynamic system means what? Memoryless system means output at any time instant can depend on the present value as well as the past and future values also. Dynamic. Now if you observe, I'm going to calculate the output at n, for which I'm coming from minus infinite to the present input. So it cannot be a memoryless system. Sorry, it is memoryless system given, no? So static system. So memoryless system is static, no? Static means what? Output at any time instant must depend only on the input at that instant only. Suppose if I take y of t is equal to some 10 times x of t. See, output at any time instant is depending on the input at that instant only. So this is static, I can say. Otherwise dynamic, no? Here I am calculating the output at n, for which you are coming from minus infinite to n of the values of input. So it cannot be static. So it is dynamic. So it is a system with memory. Option B cannot be the answer. Now for checking the invertibility, okay, for checking the invertibility, apply x of n is equal to del of n. Y of n is what? Summation k varying from minus infinite to n del of k, which is nothing but u of n. Apply x of n is equal to some 2 del of n. To u of n. Here I am giving two different inputs and I am going to get two different outputs, which confirms that it is a invertible system. Invertible system, it cannot be non-invertible system. And what is this averaging system? Averaging means what? Sum of the numbers, see, sum of the numbers by total numbers. Yes or no? Average means what? Mean. So averaging system means it will look like this. So what happens if I do this summation? So I'll get the sum of all the values. If I divide this with the total width 2m plus 1, so this becomes an averaging system. Averaging system, right? So it cannot be averaging system. So option A will become the answer. Option A will become the answer. 2 marks you can take. Averaging system is what? Sum of all the samples by total number of samples. Minus m to m means total number of samples will be 2m plus 1. So this is what is known as averaging system. Averaging system. Okay, fine. This is given in GATE 2003 ECE, old question. Let P be linearity, Q be time invariance, R be causality and S be stability. A discrete time system has the following input-output relationship. Y of n is equal to x of n if n greater than or equal to 1, and 0 n is equal to 0, x of n plus 1 for n less than or equal to minus 1. The above system has the properties A, B, C, D he has given. Come on, try to solve this one. Try to solve this one. Any answers? First of all, try to simplify the given definition. A, B, C, D. Come on. Option C. Manoj has said option A. Nandakumar has said option C. Okay. Any more answers? Look here. How to solve this problem? Before this, let me tell you a small concept that suppose if you have an application of drawing the signal. Look here. Suppose if you want to draw the signal, observe here all of you. If you want to draw the signal, how we are going to draw? First of all, we must define the signal. We must define. How we are going to define? X of n is 1 by 2 whole power n. U of n means what? U of n exists from 0 to infinite. So I can define it as n greater than or equal to 0, and it is 0 for n less than 0. So this is the definition of the signal, so that by giving different values of n from 0 to infinite, I can draw the signal. N is equal to 0, 1. N is equal to 1, 1 by 2. N is equal to 2, 1 by 4, and so on. We can draw. Suppose in the same way, if I ask you to draw the shape of this signal, 2 power n u of minus n minus 1. Suppose if I ask you to draw the shape of this signal. Now how you are going to draw? First of all, define this one. Now the signal is 2 power n. From which value to from what point to what point this signal is 2 power n? 2 power n means you have to expand this one, u of minus n minus 1. So do you know u of minus n minus 1 exists from which point to which point? If you don't know, also no issues. So first shift then scale we know, right? So u of minus n minus 1 means u of n is there with you. First shift, consider this to be y of n. Scaling by minus 1 is nothing but reversal. So u of n means exists from 0 to infinite. U of n minus 1 means 1 to infinite. So y of n exists from 1 to infinite. Y of minus n means minus infinite to minus 1. So this signal exists from what value to what value? Minus infinite to minus 1. Or I can simply write n less than or equal to minus 1 and 0 for n greater than minus 1. So substituting different values of n, 0, minus 1, minus 2, minus 3, minus 4, minus 5, I can draw this signal. What happens if I substitute n is equal to minus 1? 2 power minus 1 is 1 by 2. 2 power minus 2 is 1 by 4. I can draw like this. This is the shape of the signal. Right? Now, if you observe the present problem, what is it? Y of n is x of n for n greater than or equal to 1, and is x of n plus 1 for n less than or equal to minus 1. Now, can you write this signal like this? Y of n is x of n for n greater than or equal to 1 means how can I write? From 1, no? So u of n minus 1 plus it is x of n plus 1. N less than or equal to minus 1 means how can I write? U of minus n minus 1. U of minus n minus 1. Right. Now you can check linearity. Linearity means what? First of all, apply x1 of n. Second, apply x2 of n. Third case, apply x1 of n plus bx2 of n. For additivity and homogeneity, definitely it will be linear. So P will be satisfied because P is linearity. Q is time invariance. Observe here. Here x of n multiplied with this one. No, input delay means only this input will be delayed. Output delay means wherever you have n, replace with n minus n naught. No, so we are having n here, n here. So input delay will not be equal to output delay. So P is satisfied, Q will not be satisfied. Coming to R. R is what? Causality. Output at any time instant must depend on present and past but not on future. So x of n plus 1 is there, no? X of n plus 1. Right? So it is non-causal. And S is stability. Stability means if you apply bounded input, definitely from this input output relationship we are going to get bounded output only. So P and S are satisfied, but Q and R are not satisfied. Option A will become the answer. Option A is the answer. Option A is the answer. Linearity is satisfied, stability is satisfied, but time invariance is not satisfied and causality is also not satisfied. Right? Because here, if I substitute y of minus 1, y of minus 1 means what? Here this term will become x of 0, right? For minus 1, 0 is future value, non-causal. So linearity and stability are satisfied. Right. Let's look at the next question. You can take 2 marks. Okay. This is given in GATE 2017 Electronics and Communication paper. Consider single input, single output discrete time system with input x of n, output y of n. Input x of n, output y of n, where input and output are related like this. N into x of n for 0 less than or equal to n, less than or equal to 10, and is x of n minus x of n minus 1 otherwise. Which one of the following is true about the system? It is causal and stable, causal but not stable. It is not causal but stable. It is neither causal nor stable. Come on. What is your answer? Any answers? Any answers, my dear friends? It is causal and stable. Okay. It is causal and stable. See, first one is what causality is asking, no? So causality means what? Output at any time instant must depend on present and past but not on future. So here causality, if you check here, yes, x of n minus x of n. Yes, it is causal. Causal. And stability. For stability, apply bounded input. If you are going to get bounded output, yes, your system is stable, otherwise unstable. Now I'll do one thing. Let's check stability. For that, apply x of n is equal to u of n, bounded input. Discrete case, no? So what will happen? Y of n is equal to n u of n, 0 less than or equal to n less than or equal to 10, and it is u of n minus u of n minus 1 otherwise. Now if you observe, u of n minus u of n minus 1 is what? The first difference of discrete time unit step. This is nothing but del of n. Del of n. And this is in the form of ramp. Nu of n is ramp, but the values are taken only from 0 to 10. 0 to 10. Okay, fine. And for all other values, it is del of n. Means the output I can show like this. 0, 1, 2, 3, 4, 5, 10, 11, and so on. Look here. Here, the output will be like this. For 0, 0, ramp means what? This is R of n, no? For 1, 1, for 2, 2, for 3, it will be 3, and so on up to 10. So for 10, it will be 10, and from 11, otherwise it is del of n. Impulse signal you have to place for all other values of n, because it is del of n, right? Now if you observe the output, it is bounded only, because if you observe the nature of the output at any point, at any time instant, it is not going to the value infinite. So bounded input is producing bounded output only, in which case you can confirm this to be stable. So it is causal and stable system. Causal and stable. Causal and stable. Option A will become the answer. Right. This is given in GATE 2017 electrical paper. Consider the system with the following input-output relationship. Y of n is equal to 1 plus minus 1 whole power n into x of n. The system is, he has given 4 options: invertible and time invariant, invertible and time varying, non-invertible and time invariant, non-invertible and time varying. Come on, which is the answer? And my question, I'm adding, check linearity also. Check linearity also. Any answers for this? Option D, non-invertible and time varying. See, what is the input-output relationship? Y of n is equal to 1 plus minus 1 whole power n into x of n. See, this is linear or non-linear? This is linear. Time invariant or time variant? Time variant. Time variant. Now, for checking invertibility, what is our normal practice? Our normal practice is that we'll apply x of n is equal to del of n. So y of n will be 1 plus minus 1 whole power n into del of n, or this is del of n plus minus 1 whole power n into del of n, right? So what will happen? X of n, we know that x of n into del of n is nothing but x of 0 into del of n. So what happens if I substitute n is equal to 0? This becomes 2 del of n, right? What happens if I apply x of n is equal to 2 del of n? Y of n will be 1 plus minus 1 whole power n into 2 del of n, which will be 4 del of n. Now if you observe, two different inputs are producing two different outputs. So you can conclude that in exam you'll put it as invertible. But what happens if I apply x of n is equal to del of n minus 1? What happens if I apply x of n is equal to del of n minus 1? So what could be y of n? 1 plus minus 1 whole power n times del of n minus 1. This is del of n minus 1 plus minus 1 whole power n into del of n minus 1. So substitute the value of n to be 1. This will be 0. In the same way, what happens if I substitute x of n is equal to del of n minus 3? Y of n is again 1 plus minus 1 whole power n into del of n minus 3. So del of n minus 3 plus minus 1 whole power n into del of n minus 3. Substitute the value of 3 here, which will be 0. But here for the same input output relationship, if I apply these two inputs, I'm going to get the same output. Now how you are going to classify? Invertible or non-invertible? It is non-invertible. But in exam, how a student after reading many subjects, he will know that he has to apply these kind of inputs, del of n minus 1 and del of n minus 3, so that the system becomes non-invertible. It is very difficult for the student to examine with these kind of inputs. So nobody can do anything if a problem from invertibility comes in the exam. All of you are in trouble. Unless the key comes, all of you are in trouble until the key is released, because the definition of invertibility is framed in such a way that different inputs must produce different outputs. Look at what is the definition of invertibility? Different inputs must produce different outputs, but they have not given the definition in such a way that what kind of inputs we have to apply. Different inputs means infinite number of inputs will be there, no? So it is very difficult for the student to judge for these kind of problems. This is non-invertible. At least some discount is there. At least we would have got some concession if the system is linear time invariant. If the system is linear time invariant, we can judge invertibility based on impulse response. Based on impulse response, but our system is linear time variant. Our system is linear time variant system. So that hope is also not there. So the only thing is we have to pray that the question from invertibility should not appear in the exam, because if this kind of question comes, everybody who are writing the exam will be in trouble. Okay, everybody will be in trouble, because how can the student know that he has to apply del of n minus 1 and del of n minus 3, del of n minus 5, del of n minus 7 to check invertibility? He don't know, because the definition is different inputs must produce different outputs. What kind of different inputs? No clue is there, right? So everybody is in trouble, right? So this is linear, linear time variant and non-invertible system. So non-invertible and time varying, option D will become the answer. Option D will become the answer. See, the reason for checking in linearity is, suppose if your system is linear time invariant, then you can check invertibility, causality, stability based on the impulse response. But our system is non-linear time varying. Sorry, linear time varying. Our system is linear but time varying. So this hope is not there. Okay, so everybody is in problem. Fine. Come on. Given y of n is equal to, this is given in IS Electronics and Communication 2004. Given y of n is equal to summation k varying from minus infinite to n x of k, which one of the following is inverse of the system given above? Very simple, very simple. Very simple. What is this operation? This operation is summation or accumulation. What is inverse of summation or accumulation? First difference. So y of n minus y of n minus 1. That's it. Very simple. 15th one. Okay. This is not given. I am expecting this one in GATE 2022. My expectation. 15th one. Discuss the invertibility for y of t is equal to u of x of t, y of t is equal to sigma of x of t, rect of x of t, and real part of x of t. Invertibility you have to check. Invertibility you have to check. Come on, try to solve this one. If you can draw the input output relationship, then you'll get the invertibility. U of x of t means Input output relationship will be like this, no? If x of t is greater than 0, y of t will be 1. If you observe here, many inputs will produce the same output. Invertible or non-invertible? Non-invertible. I'm not getting any answers. Not getting any answers. Signum of x of t. Signum of x of t. So it will be like this. Signum of x of t. Invertible or non-invertible? Non-invertible. Rect of x of t. Many inputs will produce same output. Invertible or non-invertible? Non-invertible. Y of t is equal to real part of x of t. Invertible or non-invertible? Invertible or non-invertible? So Shashi has given non-invertible, non-invertible, invertible. Real part is non-invertible. Shashi, invertible. Real part of x of t. Look here. What happens if I give 2 plus j3? Y of t is equal to 2. Y of t is equal to 2. If I give 2 plus j4, what is y of t? Again 2 different input signals. I'm going to get the same output. So invertible or non-invertible? Non-invertible. Non-invertible. Right? Or you can argue like this. If x of t is complex, if the input x of t is complex, it is non-invertible. Whereas if x of t is real, it will be invertible only. It will be invertible. You can argue like this. If x of t is complex, complex means this kind of thing if you are having, y of t is non-invertible. And if x of t is real, real means different inputs will produce different outputs. Y of t is invertible. Y of t is invertible. Right? Try of x of t you are talking about, Manu. Try. I think it will come out to be invertible only. No, try of x of t will also fail because for 1, if x of t is 1, output is 0. If x of t is minus 1 also, output is 0, right? Manu, you're asking about this one. Yt is equal to try of x of t. Try of x of t means it will come like this. See, it is non-invertible here. See, for this value, if x of t for this value and x of t for this value, you are going to get the same output. Non-invertible. Manu, it is non-invertible. Right? So in this way, you are going to verify the invertibility. And the last one is important. You can argue like this. If x of t is complex, y of t is non-invertible. If x of t is real, y of t is invertible. So this is about today's session, and hope you enjoyed this session. Please give your reply. your reply matters a lot so that we can have some modifications in future. And tomorrow, look here, tomorrow I'm going to start an important unit, interesting unit known as LTI systems. If you want to enjoy, please come tomorrow to tomorrow's class. LTI systems, in which we'll see what is the concept of convolution sum, convolution integral, properties of convolution, properties of LTI systems, step response. So many concepts are going to come, and we are going to play with problems like anything from tomorrow, right? LTI system. Definitely, I'll share the PDF, and you must propagate, you share the session, today's session, to your friends and inform them that tomorrow LTI systems is going to start, which is very important session, and I can guarantee you that you'll enjoy like anything. LTI systems, very interesting session, right? You can follow me on Unacademy, unacademy.com @kvswamy. And my dear students, one more thing I want to say, that you can join my Telegram channel. All of you join my Telegram channel, KVS GATE. KVS GATE Telegram channel. After the class, all of you join this channel so that we'll have a lot of discussion regarding the questions and all. KVS GATE. We can have a lot of discussion regarding the subject. Okay, Telegram channel KVS GATE. Fine. And these are our channels. This is our channel Kreatryx. Please inform your friends that we are going to discuss valuable matter in our channel, which you cannot find in other channels. Okay. This is mechanical production. This is chemical and civil, computer science, Unacademy GATE questions. This is computer science channel, Unacademy GATE English, electrical junction and apti express. And finally, thank you students. And tomorrow, don't forget to attend tomorrow's session on LTI systems. LTI systems. Linear time invariant systems. We'll see what is the beauty of these LTI systems. What we can do with LTI systems tomorrow, we are going to see. Don't miss this class. Okay. Tomorrow we'll meet at 7:30 AM. Thank you.